Hi, this is the lecture overview of 4.3. Now, this is one of those sections that actually take quite a while to teach, even in my regular classroom. It's going to be very hard to get these things in 5 or 10 minutes, but I'm just going to do one example just to get you going here. But the graphs of quadratic functions is what this is all about. And what we're going to do is figure out what the graphs of how to sketch a graph is. Now, well, the problem with these is it depends on which shape it's in. Since we did not talk about completing the square in an earlier section, we require two ways to be able to do this because the function might be one way, one problem, and another way on another problem. And those could be in standard form or general form. Okay, I gave you two examples. One of them is in standard form and one of them is in general form. And if it's in standard form, it looks like this. But it's when it's the good thing about standard form, when it's in standard form, it's the vertex is basically staring you in the face because it's just whatever that number, the opposite of that number, and what k is. So it's hk. And the axis of symmetry, which again, this is something we discuss in class. It takes a little while to describe what axis of symmetry is, but in essence, what it is basically a vertical dotted line that basically cuts the parabola, which is what these things are, in half. Okay, and what it's there for, it's not part of the graph technically. It's just a tool to help us to graph it. So basically, if you have a parabola and you got a vertical line right through it, you got one point on one side and you have to find it, then you get another point on the other side that you don't have to work for. So they're symmetrical. So it's basically a tool to help you to graph them. It's not really part of the function itself, but it's what we call an auxiliary line. And now the other form is general form, and that's just ax squared plus bx plus c. Okay, so in this case, a is 1, b is 4, and c is 3. And you can use those numbers to find that vertex. Now the vertex is a point where if it's setting upright, the vertex is the lowest point. Sometimes we call that the maximum, the minimum. And when the parabola is upside down, we'll call that vertex up there the maximum. And that's actually discussed in another section a little bit later. Actually, it's got a 4.3 title, but we don't discuss it on this 4.3 right here. So now the things that we're going to be looking for here is the vertex, how to find the vertex. We just discussed that. The axis of symmetry, which is over here, okay, and the domain. Now the domain is easy because you can't miss the domain. The domain is all real numbers because you don't have fractions and you don't have a square roots pretty much. So you've got the axis, the domain is to be all real numbers every day of the week on these things. It's almost a silly question to ask on these problems because they're always all real numbers on this. The range kind of depends, and I always wait to the last minute to do the range because the range is found out once you do the graph and you just you can observe the range by looking at the graph. The bad news is if the graph is wrong, your range will be wrong. But if that's the case, there was no hope in the first place. Then the y-intercept and the x-intercepts, we did those earlier in another section, so those shouldn't be too bad. And again, I kind of look at the graph sometimes to get those as well, if it's easy. So, what I'm going to do is find the vertex on this particular point. And remember, it's hk, so it's the opposite in whatever that number is. Again, we do this in class, but that's why you have to come to class. Because I just kind of do a little quick problem here just to remind you on these little overview lectures. So 3, negative 2, the axis of symmetry is x equals 3. So let's see what we got going on so far. So the vertex is at 3, down 2, right there. And there's an axis of symmetry right through the middle. Now this is not part of the graph, it's just a tool to help us to graph it. Now the domain is all real numbers. So it's negative infinity to infinity. Now since the a is 2, the number in front is positive, and that means the graph will go up because there's no vertical reflection. So like we discussed in class, there is no upside down, so it's just right side up. And so you'll need to find a couple of points on each side of this. Now, what I would do is I'd plug a number in, a test point, maybe 4, but keep it close because you don't get too far away, because at the moment you get too far away, the graph is going to be shooting straight up a little bit. So it's not going to be very nice. So you want to stick relatively in the same vicinity as your vertex. So pick numbers that are close to that point. So I'll try 4 then. So 4 minus 3 is 1. 1 squared is 1 times 2 is 2 minus 2 is 0. Oh, that's lucky because 4, 0 is actually a x-intercept. Now here's where the axis of symmetry comes in handy. Since you've got a point on this side that's 1 unit away, you get another point on the other side the same distance away, which in essence means I found another x-intercept. And really I have the graph right now. Now to find the y-intercept, you said x equals 0, remember? So you put 0 in here, you're going to get a huge number. So it's going to be 0 minus 3 is negative 3 squared is 9 times 2 is 18 minus 2 is 16. So that's almost too large to actually scale it really nicely. So I won't even attempt it. I'll just keep it on my T-chart so I'll know it's there. So what it is, it looks something like this. And the moment I drew the graph, I said, okay, now I can identify the range because there are no points below the negative 2. So the range is from negative 2 to infinity. So the moment I saw that, I saw, okay, now I know what the range is then. So it's negative 2 to infinity. The y-intercept was 0, 16, although it's not on the graph. You can't really show it because it's so scaled so high. And then the x-intercepts, well, I got lucky there. Normally to find x-intercepts, you got to set the y equal to 0, and sometimes it just kind of falls in your lap, like this problem right here. So this is example 1. Now, there is another point you could actually know that's going to be. Since 0, 16 is up here and it's 4 units away, then, I mean, actually it's going to be 3 units away from the axis of symmetry. Then there's 3 units on the other side. So there's another point that you know just because you know this one. It's 6, 16. So I'll let you try to figure out why that's the case. I'll give you a hint. From this point to the axis of symmetry, 3 units away. So I'll let you think about that. The next example is x squared plus 4x plus 3, and to find the vertex on this one, you will use a negative b over 2a. So the h is negative b over 2a. So it's negative 4 over 2 times 1, and that's negative 2. To find the k, you plug that back in. So negative 2 squared is 4. 4 times negative 2 is a minus 8 plus 3. And looks like to me about negative 1. So the vertex is at negative 2 comma negative 1. So notice how I found the vertex not by observation, which is pretty much what I did there, but I had to use a formula. And that's the price we pay for not learning how to complete the square earlier in the book. We have to we have to choose the battles we fight, and that's one battle we chose not to fight at that time. But in doing that, we had to do it this way to find the vertex. So you're going to have to know these formulas to do these problems. So it's one of those memorization things you just have to do. I wish there was another way. I wish we could do the completing the square, but we have time constraints. So negative 2, negative 1. Then there's an axis of symmetry. X equals negative 2. Now remember now, the axis of symmetry is nothing more than a tool to help us graph it. So once you find this one, it's going to fold out to the other side once you start finding points. Now to find the vertex, I've already got the vertex. Vertex is over here. The axis of symmetry is x equals negative 2. The domain, what do you think? Domain, all real numbers because there's no fractions and no square roots, so it's got to be all real numbers on these particular problems anyway. Range, we'll hold off on that. Well, let's go ahead and do the graph by finding some points. Now, what I'm going to do is find the y-intercept first. And to do that, I'm going to set x equal to 0. So it's very similar like I did a while ago. So it'll be 0 squared plus 4 times 0 plus 3 is 3. So 0, 3. So 0 up 3 is a y-intercept. Now this one, remember, you're 2 units from that line of symmetry, axis of symmetry. So you get another point 2 units on the other side. And that point right there is found by not doing any calculations. It's used, I found it because I used my tool that I keep putting up there. That's the whole purpose of the axis of symmetry, nothing more, nothing less. Then you get these points, and then looks like the graph actually goes through -3 and -1. Let's find out if it actually does. So if we put 0 in for the y and try to solve for x, well, I think this actually factors x plus 3 times x plus 1, Gary. X plus 3 times x plus 1 equals 0. So x equals -3 and x equals -1. Well, how about that? -1 and -3. So there are indeed x-intercepts here and there. So this is a parabola, and so is this one. Now you're going to be learning a little bit later when we're doing these problems, a lot more of them, is we're going to be doing minimums and maximums. These both have minimums. Can you guess why? Because the graph is going down, it has a low point. So these things do have a minimum. Actually, the minimum on this one is -2, and the minimum on this one is -1. That's the lowest value they actually do. Again, that's a little later, another day. So, and now, so that's your domain. The range on this particular problem is -1 to infinity, because the lowest it goes is -1 and it goes up. So the range is -1 to infinity, although I'm wrong there. I should not have a parentheses. I should have a bracket. So the reason there's a bracket is because it doesn't include the point itself. And then the y-intercept, 0, 3, and the x-intercepts are -1, 0 and -3, 0. And remember, intercepts have to be written as ordered pairs, not by just numbers. A lot of people get in that nasty habit of doing that. It's a very nasty habit. You don't just write the numbers, you have to write them as ordered pairs. So that's 4.3, best I could do. It's a section that's pretty long to do. Hope it helped.